Okay. I guess we are live now. Please let me know in the comments if you are able to hear me properly and the video is visible. Yeah. Yes. Okay, guys. So today we are going to solve the Codeforces Round 1075-2. Okay. So let's start. Let's start the post-contest discussion. Just give me 1 second. Okay. Mm, right. So the video is clear and okay, guys. So let's start with the first problem for today's contest. In this problem, you are given with Peter drew a table of size h into L filled with zeros. We will number its rows from 1 to h from the top to bottom and column from 1 to L from left to right. Ned came up with an array of numbers 1, A1, A2, AN and wanted to modify the table. Ned can choose 2k numbers which should be less than equals to n from this array and split them into k pairs. After that, for each result pairing xy, he takes the cell located in the row x and column y and adds 1 to the number in that cell. If such cell does not exist, then this pair does nothing to the table. Peter supported Ned's initiative and asked him to maximize the sum of the numbers in the table. Help Ned understand what's the maximum sum he can achieve. Okay. So in the first problem, you are given with two integers h and l, and there is a table which contains h rows and l columns. Now you are also given with an array a1, a2, a3 up to an. Now you need to choose 2k integers, which means if you are choosing any k from 1 to up to some value, you will be choosing even number of integers from this array, and the 2k value must be less than equals to 1, which means you cannot choose more than n number of elements. Now you have to choose these elements in such a way that while choosing the element, you can pair two of them such that x and y, these are two elements from the chosen 2k elements, and these denote one of the cell in the grid. And this cell, what you have to do, you have to increase the value of that cell by 1. Okay. Now after increasing the value by 1, we have to find what is the maximum value or maximum sum we can achieve from this grid. The sum of the grid is just summation of I and j of the whole grid. Let's say gij. Okay, so How will we do that? Say there is an array, um, 10, 1, 4, 3, 5, 2, anything 6. And we have some grid of 3 rows and 3 columns. Now, the numbers you are choosing from this grid stays in this manner, like can uh, it's very easy to decode that. Can you pair 10 with any of the number and it will form a unique cell? It is not possible because we neither had a 10 or more as a row or 10 or more as a column. So 10 while pairing with it cannot come with either R or either C. Either it can't be row, it can't be column. So we cannot take 10, we will discard it. Choosing one can either be row or column because we have one as row and one as column available in our grid. Coming to 4, same condition, it cannot be row and column, so we cannot take it, we will discard it. 3, we can take 3 and it can be our row and column. So there are two numbers till now, 1 and 3. 5, same thing, we cannot take it. Then 2, yes, we can take 2. Now as you can see, 6, we cannot take 6 also. So we have to discard one of the element because we are asked to take 2k elements and these are never be 2k elements. So let's discard this two. And we can pair 1 and 3 together and place a plus 1 on 1 and 3. Now after placing plus 1, you can see the sum of the grid is 1. So I can state that the answer for this grid is 1. Okay. So what will be the approach for this particular problem? There are, say, there are three kind of numbers. Okay. First one, which is greater than both L and H. So these we have to discard. Alright. The second type is one which is less than L and say I am here taking that my L is greater than H. Okay. Let's assume this. My L is greater than H. So one of the number will be that it is greater than both of L and H. One number can be which is less than L but greater than equals to H. So these kind of numbers can only be they can only be L or they can come only in columns because it is greater than H. So it can never come as in row and it will always come as column. Third kind of number will be it is less than equals to H, which means they can either be row or column both. So can we count these numbers directly by while taking the input of the array? We can maintain two counts, say C1 and C2, and C1 denotes the second type of number and C2 denotes the third type of number. Alright. Now if a number is between L and H, which is a number which is C1, I have only one option to treat it as just column. Okay, there is only one option. But If a number is less than both L and H, which means I can treat it as two options. Let's take an example. So I can say that this number is universally better than this number, these numbers, because I can make it as a row or column according to my need. Let's take an example in which I have C2 as 2 and C1 as 100. Now, if you see it, I have two type of universal numbers which can either be row or column, and 100 type of numbers which can only be column. So these are the valid number. Technically, your answer, your thinking will say that your answer will be 100 plus 2 divided by 2, which gives us 51, and it's wrong. Okay, so you cannot pair all these numbers because you will be pairing column and column together. The correct answer will be you have to pair all, you have to make all both of these numbers as row, and then take two of the numbers from the column set, C1 set, then the answer will come out to be D. So by this I can just conclude that my if I am taking both of them, then my answer can either be C1 plus C2 divided by 2 if both of them are valid. But I need to take care that these numbers should not make some kind of thing which fails, like this C2 is 2 and C1 is 100, and after doing C1 plus C2 by 2 it will give me 15, which is wrong, which means I have to take minimum with C2. Why minimum with C2? Because C2 derives that how many rows or column and maximum will be made from this set of numbers. So I can directly say my answer will be C1 plus C2 divided by 2 or C2. I can take minimum of both of them. Okay, so this was the whole problem of A. Is there any doubt in this, or we can move forward to the second problem? All right. Okay. So the second problem states that on an infinite number line at point 0 sits a frog. After many years of meditation, the frog has mastered n unique types of magical jumps. The ith jump of the frog allows it to jump forward by no more than AI units. In other words, if it is what is integer k after the jump, it can land at an integer point from k to k plus AI. But magic always comes with a price. It has been cursed before each bith attempt, before bith, 2 bith, 3 bith attempt along the jumps of type I. To use the ith jump, the frog has to roll back Ci units. In other words, if it was at point k, it will first find itself at point k minus Ci, and after the jump, it can land at any integer point k minus Ci to k minus Ci plus Ai. The frog goal is to reach the point with number x using jumps while minimizing the number of rollbacks. Had the frog find the minimum number of rollback, it will have to endure on its way to reach the goal, or determine that it cannot reach x. Okay. So the problem, second problem was clear that we are asked, we are given a frog and it can perform some jumps, and we are also given with three elements AI, PI and CI. What these states, each of them? AI is the jump, PI at each BI or at each BI you are given three jumps, and after exhausting all your jumps you have to pay some price CI. Okay, so I can rewrite this particular thing in such a way is like how many free jumps I have. The number of free jumps that I can have is BI minus 1 into AI currently. These are the current free jumps which I have. Okay. Now after exhausting them by iterating on all AI and BI, if I reach point X, I can just return 0 because there is no rollback. Okay. But if I'm not able to reach that point X, I need to do some rollbacks, and each rollback will cost me CI. Okay. Now after doing the rollback CI, I will get my all the jumps and my free jumps back. Okay. So I need to find the minimum number of rollbacks so that I can reach the point X. Let's take an example to dry run on it. Say I have to reach some point 20. Then I have given the two jumps, J1, J2, with A is equals to say 5, B is equals to 3, and C is equals to 2. And another second A is 10, B is 1, and C is say 50. Okay. Now, what are the number of free jumps I have? Mhm. Yeah, before the first rollback, it can move B minus 1 into A. So I can say that it is free jumps. So let's calculate free jumps for both of them. Free jumps, first free jump is 3 minus 1 into 5, which is 10. Second free jump is 1 minus 1 into 10, which is 0. So the total distance which you have covered is just 10, but you did not reach your destination 20. How much destination is left? How much traveling is left? We can calculate that remaining traveling is 20 minus 10, which is 10. Okay, so I need to do some rollbacks. Let's see how which jump has the better rollback outcomes. So for jump 1, I have to do a rollback. So I have to give my CI points. So let's deduct C minus 2. But after that, I will get my all the jumps back. Okay. So I will get all the jumps back. So I can jump A into B times. Okay. A jumps into B times. Or I can write it as A into 5, which is 15 minus 2 or 13. So the first, if I roll back on the first index, I will get 13 more additional value to cover. But if I roll back on second index, I will get a minus 50 plus 10 into 1, which is negative of 40. Okay, so In this scenario, if I take J2, I will keep on going backward. I will go minus 40, then again minus 40, then again minus 40. So the number of rollback will increase. But J1 gives me a better output. Yes. So I will take my J1 as my rollback point, and then I can increase my uh, current location, which was 10, by 13 points, and I will get up to 23, which crosses my limit, which was 20. So in one rollback, I can just go to this point. So is this clear? Now, how can I calculate this? It's very easy. So first, calculate all the free jumps, which is just summation of pi minus 1 into ai. Okay, these are your free jumps. If it is greater than or equals to your x, which was your destination, you can just return 0 at this point. Else, you need to calculate how much destination is left. So I'm calculating remaining destination is x minus this free jumps. Okay. After calculating x minus free jumps, I will iterate over my array and take out which is the maximum output of ai into bi minus ci. The free jumps I will get after each ci rollback. Okay. Say this value comes out to be y. Okay. So how many rollbacks I have to do to cover up my remaining part? It's just remaining part divided by y. For the previous example, the remaining part was 10. I was getting a 13 rollback, 13 as my output for the rollback. So if you do, the seal value will comes out to be 1. So in one rollback, I can cover this distance. Why I'm not taking other rollbacks or other jumps? Because if I'm getting the minimum here, why to take a 14 or 15 with it? When dividing with the minimum, it will always give me the better result. That's why I am taking always the minimum output and just doing a seal value with the remaining part. So this was the question, second question. Any problem in this? Else we will move forward to the third part, third problem. Alright, so let's move towards the problem C. Uh, C1. Okay, it was problem C1. So in this particular problem, this is the easy version of the problem. The difference between the versions is that in this version, 2 to I to n minus 1. Note that a correct solution for the hard version is not necessarily a correct solution for the easy version. Now, the problem states that given a natural number n, find the permutation p of length n such that for each I from 2 to n minus 1, there exists a j from I to j to n such that pi is equals to pj sor I. It can be proven that under the constraint of the problem, there exists one suitable permutation p. Okay. So this problem states that we are given with the number n, and we have to construct a permutation p1, p2, p3 up to pn in such a way that pi must be pj XOR with I. All right, and we have to do for all I 2 to n minus 1, and j must be from I to n. Okay, so if I look at the constants of I, which was 2 to n minus 1, it clearly states that I am excluding the first element. I am making this array P. Then I am also excluding the last element. Okay. Now let's look at as that while XORing with index, I need to get some value Pi, which should be unique. Now each index will be unique from 2 to n minus 1. All the indexes 2, 3, 4, 5, they all are unique. Their bit set is unique. I can try to make all the values on these indexes same as them or something which is unique for them. Now, to make them unique, I will try to make I will try to take pj as my the last element pn, because pn is not affected by its XOR, because we are not XORing pi, taking I is equals to n. So I can make my pj as pn. Now I have to choose some value, and the best value to choose for pn is always 1. Why? Because 1 can be represented as a couple of zeros and then 1. Okay. Now we are constructing a permutation. So the only way so that this thing will be 0 is putting is XORing with 1. If I XOR this particular element, which is all zeros and 1, with 1, I will get a 0, which should be excluded, and it is automatically being excluded because I am iterating pi from I 2 to n minus 1. So 1 is excluded and n is excluded. So if I make my pn as 1, I can say that I can easily state that after making pn as 1, I can make all the elements of pi as pn XOR with their I. Now this satisfies all the conditions of I is between 2 and n minus 1, and j is between I and n. So let's try to make some array. Say n is equals to 3. Let's take this example only. So my pn is 1. So I am putting, say this is my permutation array. I am putting here 1. Now iterate from p2. p2 is 1 XOR with 2, which gives us 3. So I can put 3 here at p2 position. Correct. Now you're left with the single position. You can just put the remaining part here, which is 2. You can put 2, 3, 1. It will become a permutation. Okay. So you just have to do this. You have to make your pn as 1, then iterate for all of the values from 2 to n minus 1. Take pi as pn XOR with I, and then you can substitute the last value and it will give you the correct answer. Okay. The only constant that helps is 2, which is less than I and which is less than n minus 1. When this converts into 1, the problem becomes a little more confusing, which was C2. Okay, so this was the third problem of today's contest. Intuition. Intuition. Look, I have I starting from 2 to n minus 1. If you look at this carefully, I does not include the first element and the nth element. Okay, so and I have to take j in such a way that it should be greater than I and up to n, and it affect should not affect the values of pi, such that if I am taking a XOR with pj and I, these value must be unique to make a permutation. Yes or no? Now you can't iterate for all j and I. Okay. So you need to just make some uh, predictions first. So I make a prediction that the pi can be XOR with a constant value, which is pn, because pn will not be affected. I am not making pn. I will just make one uh, pn, and it will be constant throughout the process while making the array. So I can put my pn as constant here, and I will take XOR with I. Now the thing is, I have to choose this pn. How I can which number I can place here such that it doesn't affect my score. I am iterating from 2 to n minus 1. I have placed n. Okay. Now if I place n here, it may affect, because as you can say, if I place, let's say, 3, then if I XOR with 1, it will give me 2. If I XOR with 2, it will give me 1. So this is okay. But what is the easiest pn you can place here? You can just do some hidden trials, and let's say you put n, you put 1. So if I put 1, it give me the better answer. It give me the correct answer at each of the scenario, and also it give me the correct answer at the mathematical part, because 1 can be represented in the number in bit form as couple of zeros followed by a single one. Okay, so these couple of zeros will help me, like, for each 2, 3, 4, 5, 6, 7, they have at least 2 bits, 2 bit set. Okay, the only number which doesn't have 2 bit set has the single bit set is 1 only, and I am not XORing it 1. Right, I am not currently XORing it 1 because it will make 0. So if I place 1 at the last position, then after doing XOR with all these values, uh, you you have heard about this property that x XOR 1 when x is odd or even. If it is odd, it will be x minus 1, and if it is even, it will be x plus 1. So this will always give me a unique value, right? While placing the values. So while I am doing XOR with 1, I can constantly place all the values from 2 to n. I can I can do XOR with all index from 2 to n with 1, and then I can place it in PI. So this will give me the correct output. Why not n? Because there will be some n which has, let's say, this is my n value, n bit set. Okay, so this is the bit set of n. Now, if I am taking a XOR with any number up to n minus 1, it will always have a bit set which has a length less than this. Uh, n minus 1 will be look like this. So it has a length less than this. And if you do a XOR with n, it will always set the first bit as on. Okay. And if you get the first bit on and you are doing XOR with all the other bits, your permutation will have values which exceeds the value of which exceed n. So that's why you cannot XOR with n. Okay. So after doing 2 hit and trials, I get that I can XOR with 1, I will get a correct output, but I can't XOR with n because of this particular case. Okay. If this is okay, then we can move forward to the C2. Okay. Let's move to C2. Okay. In this problem, it is same as the previous one, but in this version, your I can be from 1 to n minus 1. Okay. And the condition is same. In this problem C2. Now I can from 1 to n minus 1. Now we cannot place Pn as 1 because if I do XOR of P1, it will be 1 XOR 1 and it will give me 0. And this cannot be placed in the permutation. Okay. Now what we have to do, we have to think for some patterns to find this problem. Okay. The first pattern is same, which was if a number is in this form 1 and some zeros. Now this will fail because if the number has 1 and on and all the zeros are on, which is the power of 2 raised to power x, it will fail because of the same thing that by XORing this number, because it is n, so I am doing a XOR, say p of this number 2 raised to power x is XORed with some pj or 2 raised to power x. Now this number pj has all the bits on, but it is n, and my uh, my pi will up to n minus 1. So any number which is n minus 1 will always have one bit less than this. Okay, and if it has one bit less than this, it will it will be not possible to form such a number, or it will not be possible to form a permutation number from 1 to n, because if these bits are on, say I have taken 101, it has 3 bits on, so it will always take one bit from here and all the bits are copied. Okay, so this number is greater than n, it will always greater than n, so it is not possible. And if you take the similar case of n equals to 0, the bits will be cancelled out, n equals to 1, n equals to n, the bits will be cancelled out and the answer will comes out to be 0, which is also not possible to place in the permutation. So what strategy will we will follow? Okay. So the strategy we will follow here will be like the similar case as previous problem. If I'm doing a XOR with some particular value 1, if this x is even, it will be x plus 1, and if this x is odd, it will convert into x minus 1. Okay, so this just flips the last bit. uh, Now we have to look at the patterns. Let's take n is equals to, we can't take 4 because 4 is the power of 2. Let's say n equals to 6. It's an even n. Okay, so we are taking an even n. Now while taking an even n, let's make some assumptions also. Try to make an array possible. Okay. So for the first index, these are the indexes. For the first index, let's place our default value, which was 1, on the end, which we were placing at the time. Okay. Now we have to place in specific order. So because it should not exceed the limit range also. So let's find the largest power of 2 which can be placed. So I can say the largest power of 2 is here is 4. Okay, which is less than n. Okay, so I can take this as largest power here, p as my 4 value, and my current n is 6. So I need to place two values, correct? I need to take care of remaining values too. So I need to take care of these two values, and for this, how I can make the array possible? I can replace this with, say, 3. I have replaced this with 3, this value with 3. Now if I do XOR now with all the values, it will give me the correct permutation. Okay, if I do, now this will give me the correct permutation. Hmm. Just let me check if strings. Like stream is buffering. It's okay. Just let me check. Yes, it's okay. Okay, I guess it's fine now. All right. So let's start uh, putting the values. First, let's put 1 here, and then we will just place all the values. Okay. So the first value, which when XORed with 2 will give me when 2 XOR 1 gives me 3, 3 XOR 1 gives me 2, 4 XOR 1 gives me 5, and 5 XOR 1 gives me 6. Oh, 5 XOR 1 gives me 4. Okay. So I can put all these value here, and then I can place 6. Okay. So after placing 6, my current array will look like 6 3 3 2 and 5 4 1. Now I have found out that my recent power of uh, 2 which was less than 6 was 4. Then I can just swap the values here. Okay. Now how can I swap? Which values I have to swap? It will be the first part and the r plus 1 part, which was we were talking about 3. Okay, so I can just swap these values, so it will become 2 3 6 5 4 1. Now this array satisfies the condition. Okay, for every for every j there exists a valid, and for every I there exists a valid j, which makes p j's or I as pi. If you look at this 2, so for 2 there exists 3, 3 XOR 1 will give me 2. For this 3 there exists a particular value which is 2. I can take 2's or 1, and this gives me the correct output. Yes. It's still buffering. It's still buffering, I guess. If okay, okay. So for each of these values, there will exist a pj such that you will do a pj's or I. It will give me a pi. Okay. So this was the case for even. What will be the case for odd? Say n is odd, 5. Let's take n is 5. What will be the case for this? In this, let's do in the same manner. 1 2 3 4 5. I put 1 here. Or do all the XOR from 2 to n minus 1. This will give me 3. This will give me 2. This will give me 5. Now what are you left with? You're left with 4. Okay, which is n minus 1. So I can place 4 here. Okay. So to generalize it, you can say if n is odd, you can place uh, a1 as n minus 1. Then do the same operation from 2 to n minus 1 after placing a n as 1. Okay, and then you can do your XOR of I as an XOR with I. Okay, so this will give you the correct output for this, as you can see. if n is 4, then you can do 5 n or 1. 5 is or with 1, then 5 is or with 1, it gives you 4. For 3, you need to make 2. Then you can do for you can do 2's or 1, it will give you 3. For 2, you can do 3's or 1, it will give you 2. And 4 for 4, you can do 4's or 1, it will give you 5. So for n is equals to odd, it is easy that you are doing the same thing which we were doing from the previous problem. You will place the last index as 1, then do the operation for the second index to n minus 1 index, and then place the first index as n minus 1. For even, what you have to do, you have to just do the same thing first. Then after that, you have to find the largest power of 2, which is smaller than n, and then replace both of the values, p even and p of that largest power of 2, which was say p, so n minus p plus 1. So you have to replace with this value. If you replace it, the answer will be correct. Let me just check if it is working. From my side, latency is good. Not sure. From my side, there is no buffering from my side. Okay. So let's move towards the D1 problem. This one is quite interesting, and it was quite easy than the previous one. So this is the easy version of the problem, and the difference between the versions is that in this version it is guaranteed that the string s does not contain the character question mark. For the string w1 to wn consisting of characters 0 and 1, we define fw as the number of permutation p1 up to pn of the array 0 to n minus 1, such that all I from 1 to n, the following things hold. If wi is 1, then there exists such L to R, that means max of PL to PR is equals to I. If wi is 0, there do not exist any LR such that max of PL to R is equals to I. Okay. Now, given the string s1 to sn, characters of 0 and 1, and a positive integer c, note that in this version, the string does not contain question mark. Consider all the string w that can be obtained from string s by replacing all characters question mark with the following characters 0 and 1. Find the smallest value of fw among all such strings w that is not divisible by c. Or determine if the string w does not exist. Since the answer may be too large, find it modulo of 29 plus 7. Okay. Now, this problem is quite easy. So, say you are given with a string s up to sn. Now, for the hard part, it has some question marks, but currently it doesn't have any question mark. So, you don't need to take care of multiple strings w. There will be only one string w, which is the same string s. Okay. So this w will be same. So I can write it as f of s. Now f of s is count of permutations. Okay, and the permutation will be followed with two conditions. If si is 1, there is any subarray which has max as I. If si is 0, there should not be any subarray which has max as I. Okay, so let's think it as, if I want to make a permutation, let's say for the zeroth case, if si is 0, if I want to make a subarray or n permutation in such a way that no subarray contains a max as I. So let's assume that we have already placed some indexes from 0 to I minus 1. Okay, that's why we are standing at index I. So we have placed these 0 to I minus 1. They are in this order. Okay, 0 to I minus 1, and they can be in random order. All right. So it might be possible that 4 come here, 3 come here, 1 come here, 2 come here, in such a way. Okay. Now you have to place I. What is the best place to place I? So that there should not be exist any subarray which has max is equals to I. It will be the either endpoints, so that I don't include I into my subarray. So either I can place I here, either I can place I here. So if I place I at these endpoints, how many choices do you have? I have two choices. Okay. Now after placing I here, I have two choices. Let's take si equals to 1. For this case, I need to have my subarray. I need to have a subarray which has max is equals to I. Same thing, there are some indexes from 0 to I already placed on the board. Now you have to place I. What are the values where you can place I? Now you are not placing I here, because it will not make your max as I. Then you will be placing I in between these points. Okay. So what is the count of those points? It is easy to calculate. There are total of I minus 1 choices. Okay, for this part. Correct. Okay. So for si equals to 0, I have only two choices to calculate. For si equals to 1, I have I minus 1 choices to calculate. Okay. Now what you can do, you also need to check if your answer is, you know, divisible by c, then you can just return minus 1 at that point, because this case is impossible. Now how will you do that? It's basically same. If your si is 1, multiply your answer by I minus 1 choices. Else your si is 0, multiply your answer by 2 choices, and at the last you can check your answer modulus c is 0 or not. Now you need to take care also, because if you do modulus here at each of the step, then there might be some case that your answer is not modulus by c, which was earlier true and now become untrue or false. So you need to make a temporary variable which is same as answer in that start, which is same as 1. Now this temporary variable will be also multiplied at the same time by I minus 1. Now you have to take modulus with C here. Okay. So multiply by 2 and they take modulus with C. This will and use this to check if you're use this to check if t is 0, then take your answer as minus 1 and output it, else you can just output your answer directly. Okay? So this was d1 and this is quite easy. We can try run on some test case. Let's say s is 1011. I'm not taking C currently. You can take any C. Now if s is 1, now currently I have a single element 0 on the board. I can place 1 here or 1 here. So there are two choices. It will make 1 0 or 0 1 as my permutation. So current choices is 2. Now there is 0 here. Okay. Now for 0, I can place 2 in between these. Oh, I guess I did wrong. I did just opposite, I guess. Let me check. Yeah, for 0, there exists a subarray. One there exists a subarray. I just forgot. Okay. So 1, there must exist a subarray. So your current element is 0. You are doing for 1. You can place only this only at here with reciting this. So the number of choices will be 1 minus, what's it, 2 minus 1, which is 1. There is only one choice to place here. Okay. Now coming to 0, there you have to place, you can place 2 here, 2 here. So you have two choices to do this. Coming to this one, you can take any example 201. Now you can place your 3 any of these places. It will become either 2301 or 2031. So you will again get two choices and so on. Okay. So this will be the flow of the code. Okay. So this was the whole approach, that for si equals to 0, you don't want to place it anywhere, so that there must exist, there should not exist any subarray which contains your max is I, so you can just place it at any of the corner points and you will get two choices from that, left and right. For si equals to 1, you want to make it a subarray, so you will place this in between from 0 to I minus 1, so you will have I minus 1 choices. So this was your D1 problem. Okay. Uh, is this clear, guys? Very hard to visualize. Yeah. Okay. So that was all from my side. I was not able to complete my T2 by the time being. I will definitely going to observe it. The idea for the D2 is same. The idea what I had in my mind, I was not able to like complete the code. So I can just tell you the idea which I had, that there are three type of indexes: was 0, 1 and question mark. So uh, 0 and 1 is clear from the previous problem, that for 0 you can have two choices, and for I 1 you have I minus 1 choices. Now for the question mark, I want to take the minimum possible choice, uh, so that the answer should not be divisible by c. The for idea was that I will take the minimum choice so that the answer is will not be divisible by c. So if my zero zeroth choice give the minimum output, or my first one choice give me the minimum output at that particular index I can say that I will take that as my question mark. Now I will fill this greedily first, then I will get my some answer and the temporary variable same. Now there will be one case, if this answer is not if this t is not 0, then my answer is correct. But if my t is 0, okay, t comes out to be 0, then this means that the string I have made is wrong. So I will just go back at all these question marks, and these values will be I can store them in some sorted array of these values. Okay, so these cost, I can store them somewhere, and then I will just get back to this particular question mark, and my t is 0, so I will update this question mark. If I have taken the zeroth value, I will uh, take my question mark. If it was earlier 0, then I will take it as first. If it is was first, I will update it to 0. So the ratio of this will be the new value by old value. Okay, I need to store this also. So I was making a double array to store ratios also, a structure for me in a vector, so that you can store cost and ratio at the same time, and then sort them accordingly, so that you get the minimum cost and minimum ratio at the start. Okay, after doing this you can just track back again. If your answer still persists to be not possible, then you can just track back again to that particular question mark and do this. I guess it will not be solved in by solving only one question mark. You will need to solve at least two or more. Okay, two or more question mark when changed, then it will give me the correct output. That was my plan during the problem. I was thinking this. I'm not sure if this work or not. I was implementing this, but time was up. So yeah, so that was the idea for T2, which I had in my mind. So that's all from my side. Okay, so let's end this stream now, and thank you for joining, guys.